Today we're looking at a Newick file, a machine-readable phylogeny published supplementary to this article, Borissov et al. 2022 or 2023. Data is on Dryad. Download dataset. And you get a zip file with 5 files in there. So we probably want the tree with the most, which has used the most sequence data, and Bayesian tree, which is this one. And it looks like this, well, in Newick format. Now we'll look at the terminal labels, and for those with a bit of experience with Linnaean names, they might recognize that this looks like a typical species name, i.e. part of the string, and this looks like a typical species name which would be used in insects, i.e. not the whole word but starting at 2 or 3 characters in. So this is the tree this corresponds to, and you can see in the printed version that they've used a abbreviation of the genus name, P dot space, then the species name, but in the tree file there's no character delimiting the genus abbreviation from the species name. Normally you would have at least a dot or a space or an underscore, so this just looks like one word. And unfortunately it complicates further. Firstly, the use of abbreviation in a genus name when you have several genera, particularly where you have cell genera, some starting with the same character, the same letter, which means so in some cases it's abbreviated to 1, other cases abbreviated to 2. So you have a P and a PH. So you can't tell the script to pull out the first, to separate the first character from the remaining to get to the genus species, because you don't really know this. And so we've got to so we can't use this as provided. We have to interpret it. We need to look at the result and interpret it, and then account for whatever. So you'll see that it's a study of a given genus, and they've abbreviated that in the figure. You'll see it's got some members of a different genus stuck in the middle, and the outgroup also is named in full, but in the tree file these are all abbreviated. So what that means is when we parse this, we have to pull out these individually. So here's a few regular expressions. So search for this, which after studying the file I find it here. Here's a full name, so replace that string with a full name. Also that's a second outgroup which is in this tree. And anyway, this which superficially a computer code might interpret this like a single taxonomic name, but it's a combination of 2 different ranks. Again, genus and species, so we need to replace this with the full name, and again with this. And then after we've done that, the remaining ones should all be, as far as I can see, these are all one genus, and with a single character. So search for P and a series of other letters and effectively replacing the P with a full genus name and an underscore, and the characters which are following it, which should be the species name. And after we've done that, we can then deal with the more common issues. We also have a few species repeats. Now they put characters after that, so that's fine. These are unique labels. If you have a species repeat, you can't just use an identical name. You have to, or actually a lot of software cannot read it. It will just crash if you try and input the identical. So they put A, B, and C to denote the species repeat. So several of these, which I've just removed. And then finally we should have, so this is the tree that the authors provide. There's this one on the left, corresponding to, and so you can see the labeling they've used, and then after parsing we have, I have produced this. So we have a format which is a lot more readily, which we can map to taxonomic frameworks. We have a standard genus name underscore species names. So notice we do have these. It's not all a single genus. We have a few others stuck in the middle and the outgroup. But this can now be. This is now ready for synthesis. And that's it. Job done.